In today's lesson, we're going to be looking at matrix multiplication. Please be sure to subscribe so you don't miss out on any future videos. Unlike matrix addition and scalar multiplication, as we've discussed in previous videos, please see the link of the video in the description. The product of two matrices is not a component-wise definition. Let's look at an example. Given matrix A and matrix B, we would like to compute AB. To determine if these two matrices can be multiplied together, we must first determine the size of each matrix. In this example, the size of matrix A is 2 by 3, and the size of matrix B is 3 by 2. Note, in order to perform matrix multiplication, the size of the two matrices do not have to be the same. However, the number of columns of matrix A must be the same as the number of rows of matrix B. In this example, the number of columns of matrix A is equal to 3, and the number of rows of matrix B is also equal to 3. Since they are the same value, we know that we can perform matrix multiplication on these two matrices. In order to predict the size of matrix AB without doing any calculations, we can analyze these two values. We can determine the size of matrix AB by looking at the number of rows in matrix A and the number of columns in matrix B. Therefore, the size of matrix C will be 2 by 2. Next, the first row of the product, C, matrix C, is computed by taking the dot product of the first row of matrix A with each of the columns in matrix B. Let's look at the first coefficient. In order to determine C11, we need to take the dot product of the first row in matrix A with the first column in matrix B. Therefore, we can see that coefficient C11 can be determined by multiplying 4 times 1 plus negative 2 times 3 plus 1 times 5 to give us a value equal to 3. Next, we will look at the second coefficient. To determine coefficient C12, we need to take the dot product of the first row in matrix A with the second column in matrix B to get a coefficient value of 6. And then we perform the same procedure. In order to determine coefficient C21, we need to take the dot product of the second row in matrix A with the first column in matrix B in order to get a value of 21. And the last coefficient can be determined by taking the dot product of the second row in matrix A with the second column in matrix B to get a value of 26. Therefore, when we perform matrix multiplication, the product is right over here in the corner. Next, we want to determine if the product C equals AB is the same as C equals BA. In the previous example, we computed the product C equals AB, and we determined that matrix AB is a 2 by 2 matrix. Next, we want to compute matrix C equals BA. First, we must determine the size of each matrix. Matrix B is still a 3 by 2 matrix, and matrix A is a 2 by 3 matrix. In order to determine if matrix multiplication can be performed on these two matrices, we need to make sure that the number of columns in matrix B is equal to the number of rows in matrix A. Since the number of columns and the number of rows in this example are the same value, we know that we can perform matrix multiplication on these two matrices. We can also predict the size of matrix BA without performing any calculations by looking at the number of rows in matrix B and the number of columns in matrix A. And this tells us that the size of matrix C equals BA is 3 by 3. Now, since the size of matrix BA is a 3 by 3 matrix, and the previous example, the size of matrix AB was a 2 by 2 matrix, we can already see that C equals AB is not the same as C equals BA. Now let's perform the matrix multiplication to get the product BA. In order to determine the first coefficient, C11, we must take the dot product of the first row in matrix B with the first column in matrix A. And that gets us a value of 4. Next, to determine the coefficient C12, we must take the dot product of the first row of A with the second column in B. And to determine coefficient C13, we take the dot product of the first row in matrix B with the third column in matrix A to get a value of 7. And we use a similar approach to determine C21. Now we take the dot product of the second row in matrix B with the first column in matrix A, which gives us a value of 12. And for C22, we take the dot product of the second row in matrix B with the second column in matrix A to give us a value of 2. And to determine coefficient C23, we take the dot product of the second row in matrix B with the third column in matrix A to give us a value of 15. And for the last row in matrix BA, to determine the coefficient C31, we take the dot product of the third row in matrix B with the first column in matrix A to give us a value of 20. To determine coefficient C32, we take the dot product of the third row in matrix B with the second column in matrix A to get us a value of 2. For the last coefficient, we take the dot product of the third row of matrix B with the third column in matrix A to obtain a value of 23. Therefore, the final answer in the matrix of C equals BA is shown in the bottom right corner, and a similar approach can be used when multiplying different matrices of different sizes. Thank you for watching. Please like, share, and subscribe.